Right. Hello guys. Today I'm going to do those two move zeros and two sums. This one is like quite difficult. Like if you make a time complexity of O n squared, then it's easy. But if you want to make it less than that, then it's quite difficult. Let's do this first. This one is quite easy. It's quite easy. So what we're gonna do, what it wants us to do is to put those zeros at the end, and those who are not zero, we cannot change the order. We just put it in the beginning and put zeros at the end. And the thing is, we can just put everything that is not zero to the front and don't care about the one at the end. And in the end, we write another for loop to finish this part. So I've already done that, but let's write that again. So let j is equal to 0, and that j is for recording the number that is not 0, and then we loop over so that I is equal to 0, smaller than counts I plus plus. Then we change nums, but j is equal to nums I, and then j plus plus. And we only do that when that is not 0. So nums I is not 0. It's not equal to 0. Let's make the indentation looks a bit better as well. And after that, we can write a for loop. For let I is equal to, or maybe we can just say, we can write a just j is smaller than num store length, and we just set all of that nums j to 0. 0, and then j plus plus. That's pretty much it. Let's do this. Easy, quite easy. But this one took me a long time, and I didn't figure it out in the end. I just, once you do a dumb way and you can see other people's solution, and then it's basically I just copied other people's solution here. It's so much faster. But let's write the dumb way first. Let's read the question first, and then we do the dumb way first. So basically that's an array of nums, and we just want the index of two numbers in that array that added to 9. And they say that in the array there's only one solution, and you cannot select the same one twice, and you can return the answer in any order. So 0, 1, 1, 0 doesn't really matter. So let's do this. The first thing comes to my mind, of course, is just use this one and compare this one with this. Oh, sorry, add this one with this, and see if it's equal to 9. And if it's not, then the second one compare with this, and the third one compare with this and this. So I think that's pretty much everyone's first thought. Just let's implement this like 4, I is equal to 0 and I is smaller than nums dot length plus. And so we need another nested for loop and saying that now this one is need a little bit think, so we compare the next one, so the index which is bigger than n, so I plus the 1, and then j is smaller than nums dot length as well, and j plus plus. And now we just say if nums I plus nums j is equal to target, return I and j, right? So let's run this. Let's submit it. So time complexity of this is n square. If you look at the map here, a lot of people, if they use n square, they'll be here. But some people use this like frequency counter, use a hash map or an object to do this, then it'll be a lot faster. You are here, you see, some people are smaller than me. Anyway, let's do the clever way. We did the dumb way, and let's do the clever way. I couldn't come up with it myself. If I'm in an interview, I wouldn't answer I don't think I can, but like, let's do that anyway. Object is equal to this, and we write a loop. So basically the idea, I'll explain it first. The idea is we store this one with the index. So pretty much every time we do check this, we need to loop this array anyway. So every time we check the first one of that, we're gonna use the target minus this and check if it's stored in an object that we have. I mean, the one that matches 9 minus 2. So we check if the 7 is in the object as a key. If it's not, we store 2 inside of that inside of that object, and set the key as 2 and the value as the index. So this one, the index is 0. Maybe that is not the best demonstration. This one is better. So we store 3 because firstly we check this, and if it's in the object, but 6 minus 3 is 3. 3 is not in the object because the first time the object is empty. Then so it is not in the object. Then we add 3 inside of that object as a key, and the value is 0. And then we check 2. 2 minus 6, or 6 minus 2 is 4. We check if 4 is in the object, but only 3 is in the object. 4 is not in the object. So we're just gonna store this in the object instead. So the key is 2, the value is 1. The 1 is the index of 2. And then we check 4, and 6 minus 4 is 2. 2 is inside of that object. Alright, we find the answer. So we only did 3 iterations. The worst case, we did need n iterations. And then, because we find it, then we can return the index of this by assessing the object by 2. We put this as the index and we get the value, or we use this as the key and we get the value which is the index of this number. And then we use the I, which is the loop, the index of the loop. Then we can get this. So let's implement this. I know my explanation it's pretty bad, but like it's be a lot clearer. We say it here, nums.length and I++. So we say we actually need a match number. So const match is equal to target minus nums I. So that's the one we are looking for inside of this object. So we want to look the match inside of this object. So we say object match if it exists or if it is 0, because 0 is empty. It could be the 0 index. So we say or object match is equal to 0. If it's, or like we say this one is not equal to undefined, then it's okay as well. But we just say it exists, and if it's 0 or if it's anything that exists, and then we're gonna return the object match. So that's index of the match number and the I. Well, otherwise we just store that number, this nums I, inside of that object. So object nums I as a key, and the value is gonna be 0. So yeah, it's gonna be I. So that one is a lot faster, because when we are assessing things using like this key to assess this value, it's constant time. So instead of nesting a loop here, we search by assessing a hash map or like an object. That will be a lot faster. And the reason that works is that we don't really care, like there are like 10 2s or something, because if we have a new 2 here, it's gonna override the 2 before it. So if we have 2 2 2 2 2 3 2, then we only get the index of this. But here they say that's only exactly one solution, so this works, otherwise it won't work. And another thing is this one doesn't change anything yet, just because we only have exactly one solution. That makes this work. Otherwise we have to use this, I guess. Have to use the dummy method. Let's see if it works. Oh, wait, what? Okay, OPG. You're stupid. Let's see. Yeah, alright. Let's see. You see, now we are like 100%. Perfect. Yeah, that's for today. And I think it's pretty the second question is pretty good. Like it makes me understand the object or hash map a little bit more, because we can access values in linear time, and if we don't care about repetitions, then we can use that one to reduce our time complexity significantly. So thanks, guys. See you tomorrow. Tomorrow, what we're gonna do? We have two array. I think we have two array easy questions tomorrow, right? Valid Sudoku and rotate image. We're gonna do this too tomorrow, and then we're going to go to the string, and then we have linked list. We have a reverse linked list is so bad. And trees, sorting, merge sort array. Actually, I think we did that. Anyway, dynamic programming. Oh, I'm so bad at it. And design, and math, physics, and others. So we're gonna do those two tomorrow, and we're gonna follow all the way down there. Maybe it will take us like a month, and we can finish this. Thanks, guys. See you tomorrow.